excited to explore perspectives that emphasize the core role that human activity has in learning. And so through a variety of talks, we're examining human activities like moving and making and creating, and how these activities contribute to cross-disciplinary engagement in mathematics, in science, and in the arts. And tonight we get to hear from Aileen Rizzo and Leslie Batty. Aileen is the Associate Director of the Pre-K to 12 programs at the Ames Center. She has worked in math education for more than 20 years. She's served in state capacities with the California Department of Education and various community organizations. She has earned 2 master's degrees, one in educational technology and another in math education. And she's currently a PhD student in STEM education at Texas Tech University. Additionally, she is an adjunct faculty member here at Fresno Pacific University, teaching both math and engineering courses. Aileen's work in the STEM fields fueled her to realize the importance of providing young children with powerful educational experiences and the need for advocating for the equity of women and girls within these fields. Aileen is joined tonight by special guest Leslie Batty. Leslie is a successful and well-known local artist. She has a Master's of Art from Fresno State University and an art studio near downtown Fresno. Her work explores ideas of feminine identity construction within contemporary Western society through the metaphorical lens of sewing and active dress. While continuing her art career, Leslie is also a high school visual art teacher who believes in the importance of giving back to the community that she loves. So together, Aileen and Leslie present their talk tonight, The Symbiosis of Art and Mathematics, Harnessing the Power of Integration to Produce Greater Equity. In this collaborative presentation, they challenge the idea that mathematics only happens in mathematics classrooms and explore how humanity's attraction to aesthetics and creativity can produce deeper learning in mathematics, as well as create avenues for greater inclusivity. They will share the process of looking at research, lessons they've created together, their experiences in bringing these lessons to the classroom, and their passion for seeing this type of intentional collaboration grow throughout the Valley and beyond. So Aileen and Leslie, thank you for joining us tonight.
Thank you. Thanks for having us. So we're going to get started by creating some norms, because I thought it was really interesting that at the Ames Center, my clicker doesn't like me. Sorry. There we go. All right, so at the Ames Center, one of our core values is human-centered, and to remember that we're human-centered. And I thought that that was a great way to just create a norm today, because we're going to be doing some collaborative work and some work around art and mathematics. So I'd like to invite you to read this with me today, kind of setting the norm and kind of setting the stage for what we're doing today. So I'll start, and then we'll all just start reading together. We respect and celebrate all people as beautiful and complex beings whose emotions, states, personalities, families, and curiosities are assets for learning and play, role in making us uniquely human. As we come together and collaborate, we respect and celebrate what each bring to the space. So we're just going to set that as our norm as we fold today and think about equity in terms of a human-centeredness, right? And as I think about this presentation, I'm really grateful for just this opportunity to kind of build off of some of the work that has been done. I've used origami in my own classroom, and I know with some of you in the master's program, we've done a lot of origami. But this was a unique situation in which I was able to go into an art classroom and use origami to teach mathematics. And it wasn't exactly the place where I think that is done intentionally. But I love this quote that I found from Albert Einstein. And I wanted to read to you another small quote from a research article. It said, the addition of A, or arts, to STEM is not just the addition of the arts to curriculum. Instead, it is an awareness that the arts and the sciences are more deeply connected than traditional disciplinary boundaries reflect. They are connected in ways that integrate them as inherently humanistic enterprises, which allow us to experience and engage with the world in a profound and transformational ways. So I'm really grateful for this opportunity, and I wanted to thank Leslie, of course, for allowing me to come into our classroom, to that space, and for her to be flexible and for me to be flexible and vulnerable in that space. And I wanted to also acknowledge, as we talk about human-centeredness, a mutual friend that really connected us. And I just wanted to acknowledge her because it was a special connection that she saw in both of us that allowed us to make a mutual connection, and then for that to flow into the work that we do. So I'm going to hand it over to Leslie and let her introduce herself.
I'm also very grateful for this opportunity. So thank you for having me here. Thank you for coming into my classroom. And it really, it's my pleasure because the kids loved it. They had a great time. So I started out as a double major English and art, and I had to decide which one. And in the end, I felt like visual language was my voice more than, even though I love to write and I love literature. But so I have, that is sort of my background. And then I decided I wanted to teach at the college level, and which I did for 6 years in the community college district. And then some things happened in our family, as it were, and I wasn't able to continue that. So I decided to do high school, and I applied, and I am now in the credential program and teaching high school at the same time at Sunnyside High School. So, and I thought it can't be that different. 18-year-olds and 19-year-olds are only a year apart, but it's really different. So, but I really love it. I really do. And it's different in interesting ways that I couldn't have imagined. So let's see. When I was adjuncting at City College, Fresno City College, I also was having a professional studio practice, and I did quite well. And I've been able to have opportunities to show my work throughout California and overseas internationally, and have gallery representation in San Francisco, which isn't an easy task it's not easy to do. So it was a lot of work, but it was very gratifying, and I had great support. But I really feel like teaching is really a connection to my studio practice. It seems they go together, and I can't really separate them. So I can't separate them even in my own mind. They go together. So I've had to make some adjustments with high school, being a little different, but it's definitely part of the big picture for me as an artist. So I think that pretty much covers my background.
Okay. So we wanted to go into a little bit of like why, or what was the reasons behind our ideas to collaborate, not only because Paul asked me to do a talk, but also the idea of, even through this theme, that when he asked me to do that, I kind of was inspired already, having met Leslie and heard her talk about her classroom and what she was doing in there, really inspired me. And I was starting to see those connections. At the AIM Center, we've spent a lot of time studying spatial reasoning and how important that skill is for children when they build it very young. It's one of those profound skills that a lot of STEM professionals have. And yet intentionally, it's not really taught in our math classrooms. But as Leslie was sharing with me, and showing me pictures of all of her student artwork, I was seeing so much spatial reasoning and mathematics there. And so we wanted to share a little bit of what inspired us to even collaborate together.
So I have to say that even at Fresno State, the the art department struggles with being sort of the black sheep of the College of Arts and Humanities. And even though we have all these very rigorous applications, there is this conventional idea that art is just playing around, and it's just kind of, you know, kindergarten for bigger kids, you know, where you just get to use scissors and paint. And even at City College, when I was giving my syllabus description and going through it, if I made it sound too rigorous, the students were like, I thought this was supposed to be an easy class. You know, oh, I took art because I wanted an easy class. So, you know, you want it to be fun and play, but you also want people to understand this is an academic field of study. This is very serious. We have standards and structure, and we have applications that are very important for all the content areas. So when Aileen asked me, would you like to do a collaboration together? I was like, yes. I mean, because I see every single content area having applications, you know, with art. I mean, imagine how we would get the next iPhone if we didn't have some creative people in there pushing and extending their thinking. So I think the idea of kind of breaking through those conventional myths, we talked about how people say, oh, math is hard, I'm not a math person, or girls aren't good at math, or you know, art is, you know, just kind of the fun class. It's not really that important. We can cut that one. Or that math has no creativity. You know, all these ideas are really false, and they're very, very widely accepted. And so for both of us, it seemed like just such a fun challenge to kind of merge our ideas.
Definitely. So going back to that sense of equity, that is actually our vision at the Ames Center, an equitable world through math and science education. And for Leslie and I, and our desire to see our students rise above maybe the barriers that they have, we talked about using their voice, and we talked about not that no one has a voice, because everyone does, but sometimes we don't see value in our voice. And sometimes that value piece, it's the barrier for someone using their voice and seeing that that is valuable. And so we talked about, well, where do students see themselves, and where do they feel like they belong? And so as we were thinking about that, I was reminded of my own experiences with my daughters. So in my first year of my PhD as a student, I read a research article talking about science and the stereotypes around science. And they asked first and second graders, what does a scientist look like? And almost every child said the same thing. It's a man in a white lab coat, he has crazy white hair, you know, and it was like the stereotypical, you know, answer that most of the children gave. And so I was really curious. I have a very young daughter, but my two daughters were old enough to understand. And I went to them, and I was like so like ready to hear them answer in a different way, right? Because I thought, well, their mom's a mathematician, so they're not going to say that, right? And I said, hey, what do you picture when I say the word scientist? And my daughter's like, they both said the same thing, stereotypical, a man with crazy white hair in a white lab coat, and that was it. And I was a little bit shocked. I was thinking, you're not supposed to answer that way, you know? I felt like they didn't see themselves, because if that's your role, if you see a scientist, then do you identify with that? Do you see yourself? And so part of that assignment was to take children through a citizen science experience. So citizen science is a lot of activities that are online for anyone to do, no matter what your age. And one of those is backyard bugs. So you go to your backyard and you collect bugs, you collect specimens, and it gives you like every part to go through to collect them, to measure them, and then you try to identify them. And then there's this huge database where you put your zip code and where you're from and what bugs you collected, and if you identified some of them or not. And then actual, you know, people around the world use that data to do a lot of research. And so I let my daughters like experience that, and we talked about, you know, scientists all over the world collect bugs because that's one way for us to see how, you know, the environment is impacting or what kind of bugs are good. And we looked at the bugs. What are they doing when we found them? Did they live in the dirt? Were they on the branches of the trees or the rose bush? So we got to have a lot of those discussions. And then I asked my daughter, oldest daughter, I said, will you draw me a picture? So after we've done all of that, I told her, will you draw me a picture of a scientist? And this is what she drew. And I was so happy because that's what I wanted. I wanted there to be an image where she could see herself there. And I think that really taught me the importance of looking at students' perception, but not assuming what that is. Because our experiences that we provide for our students create the perceptions that they have. And so we really have to be intentional when we think about creating those environments and wanting to give them those experiences that have positive perceptions so they could see their places that they belong. So I took the snapshot because when Leslie and I were discussing, a lot of that was online through Messenger. We're both, you know, doing school and really busy, and that's one of the reasons I'm so grateful that she took that time out. But she's very visual, right? And she was sending me these sketches of ideas because we were thinking about what kind of lesson would we like to create. And those of you who are in the STEM Engineering Week, some of those things look like those tessellations that we built, right? And it was pretty cool to see a lot of those shapes coming out. And as we were discussing that, thinking about all the ways that she was really using math in her first year of teaching high school and the different areas that we could integrate. So I'll let Leslie talk a little bit about this lesson because this was like the first lesson that was the precursor before we taught our lesson together.
Well, and I should probably tell you too that my particular class at the high school is 3D design. And I'm actually more of a 2D design person, but they already had a few of those. So they just said, okay, well, you're teaching 3D design. And I said, okay. And I've done sculpture and I've done different 3D applications, and especially fashion design, which is kind of a 2D that turns into 3D. So I do understand the whole the spatial, the three-dimensional spatial design, but I had never really taught it to a class until last year. So this is my second year, and I've decided I want to lean more into getting my kids career ready, architecture, product design, graphic design, because I think those are the things that will be really useful, and they can also apply it to their science classes. And I have several students who go to the engineering program at CART. So we're really spending a lot of time on geometry. So this particular lesson, and this is after we've already done lots of expressive line, organic line, we've done some different things with shape, and now we're starting to talk about form. So if those of you that may not know this, two-dimensional shapes are two-dimensional and they're flat because, you know, x times y. And then three-dimensional is three-dimensional because it's x times y times z. Okay, see, I didn't know that. I just tell them length times width times, you know, the cube. You have to have three numbers to get mass or volume. I remember that. And so they learned all that, and we did some notes, and I brought some of those things too. I can pass around so you can see. But they kept saying, Miss Patty, when are we going to paint? We want to paint. So I decided, okay, well, let's do it. And I'd never done this before, and I didn't even know. I'm not sure we had really fleshed out the origami idea yet, but I thought I had seen some artwork like this. One of my friends had a show recently, and I was really amazed with this kind of, it was like a non-objective, abstract, but they were geometric and they implied form. It felt like depth. And so we talk about that a lot in our class because we're drawing and painting, but we're looking especially at 3D. So we're talking about implied 3 dimensions. So when you're looking at a photograph and it feels like you're looking far, far away in the distance out onto a horizon, you know, if you close your eyes and you touch that surface, it's very flat. But when you look at it, it reads as deep space. And so the students they're learning about this, but it takes a while to wrap your brain. So we went through some step-by-step exercises where I gave them a little 1.5-inch cardstock square and a fine point Sharpie and some watercolor paper. And everybody did this together. We put 3 dots on a paper. And I said, now, how many of you have ever played, dot to dot? And of course they had. So I said, connect the dots. Does the shape look flat or 3D? And they were like, flat. And so we did a few more dots and a few more lines. And then had them put a dot in the center and connect them all together. And I said, how about now? And they were like, whoa, it looks 3D. So they started learning how to create that illusion. And so I said, okay, now I want you to just continue on, make some more dots, start making lines, and I want you to experiment and play with what are maybe some different ways, some strategies that you can discover that make it look 3-dimensional. And so they had so much fun. I've never had my classroom so quiet and everyone so intently working until Aileen came, of course, and then we had another one of those. But they really loved it because, and the kids that were worried about, I can't draw, I can't make art, they felt no pressure because it was making some dots. And then I said, it's very important to try to keep that straight edge straight. I want you to think about being precise and not going over the dots and things like that. But they came out amazing. And then when I showed them how to do the watercolor application, I said how to put the brush, just water, just put a water wash, no pigment, going around carefully the edges with just water. And then putting your brush into the watercolor paint and you can just touch it and it will, I had kids like out loud like, whoa, Miss Patty, how'd you do that? And they were, in fact, I had to send a video to my clinicals. They were like, your students are really engaged. So that was good. But then I gave them some salt. I don't know if you've ever tried this, but if you sprinkle salt on really wet watercolor paint, it makes this amazing texture. And I have some examples I'll pass around. And then after that, I said, let's go in. They were amazed how the water created a little wall that wouldn't let the pigment go in where they, you brush the water carefully around, but if you went over, the color would only go where you had put the water. And even if you held it up like this, it would go around. Mm-hmm. So they were really having fun playing with it and discovering. So afterwards, I just said very lightly, select some colors, and I told them to hold it back and use your imagination. What does it look like that face would reflect? Maybe a different color. And so they started envisioning what the 3-dimensional implied form would look like if it were reflecting colors in outer space or something. So I don't know if that makes sense, but the kids really loved it and they got to paint. So I'm going to grab some examples.
Yeah, definitely. As Leslie was talking, for those of you who are math teachers, there's a lot of parallels there. So she talks about doing something where everyone can do it. And Leslie was sharing with me as well is that she has kids come into her class and say, oh, I can't draw. Very similar to kids who come in her class and like, I'm not a math person, right? And so convincing them that drawing is not copying something to perfection, because that's why we have photography, but that art is an expression that's much deeper than that. It's creative, it's how you do it, right? And there are conventions that you learn, but I love what Leslie said. She said, you learn the conventions so that you can break them intentionally, because that's what artists do. That's how they get known, right? And so in mathematics, we have these conventions, but we talk about having problems that have entry points for everyone. So everyone can enter that problem. But a variety of students will have a strategy that's different, right? We'll have very sophisticated strategies, very efficient strategies, right? But when we share those strategies and students come to that same point and can justify how they got there, then we have value of where everyone's at and how they see a problem and how they look at it. So I thought that was like something that was really interesting as well. Yeah. So another thing that was coming out as we were having these discussions is the vocabulary piece, right? So actual form, implied form, the actual word form. When the students are immersed in this art environment, they start building this vocabulary. But it doesn't necessarily lend itself to the mathematical vocabulary. And I think that that's where, when I came in, we added more vocabulary to what we were doing. So what is a face in mathematics? And what is an edge? And what is a vertice, right? And so now the vocabulary can layer on itself because students are seeing both of those in the same context, and it makes meaning out of those things. So before we did the fold, and before we do that today, this was a sheet of paper that was at the top showing those two definitions that they had gone through, and students create these sketchbooks, and they copy these definitions in there, and they make sketches, and they use their straight edges that she has on the table to create that for, and kind of sets the stage for what we're going to do, and shows them that the square shape on the left side was the 2D flat, and then the cube on the right side is a 3D, but it's an applied form because it's not the actual 3D form, it's implied. It looks like it's 3D, but it's actually on a 2D surface, so it can only be that. So I'm going to start getting the paper ready because we wanted to take you through some of this experience as well. You can describe something.
Okay. And so I've decided to pass out a few just because I want you to see the variety and how every student has such a different voice. So I've even told them, and they get kind of like, whoa, like they never thought of it. But I say, you know, I have almost 200 students that come through my classroom, and I can almost tell whose work is who just by the mark that they make. You know, they each have a different way of applying paint or different colors, and you start to recognize this, you know, I'm trying to think of Carlos. He always loves this yellow green, and he always likes to pair it with this kind of coral color or something. Like, and he has a certain thing that I can't even put my finger on. He's not trying to have a style. He just has a way of expressing himself through color and line and shape. And so it's almost like the artwork itself is their signature. You know, it's their own voice. It's almost like a fingerprint. They each have their own very unique way of expressing, and they are absolutely not trying. They're not trying to be Picasso or anything. They're just trying to do the assignment. And maybe, you know, just, I don't even know how to explain it exactly. They just want to do it. They hear the prompt, and then they just go. So they're not thinking, I think I'm going to channel Chagall today. You know, they're not really doing that yet. They're just like, okay, draw a line with a straight edge. Okay. But it's so amazing to me how unique each one of their pieces are. And I wanted you to see some of that variety. And this is really, I didn't go through and just select the very best or anything. These are just I just brought period 5 with me and just grabbed it, and I selected a few out. So thank you.
All right, so we're gonna do a couple models and see what our time is. And so I know some of you are in the STEM program. I mean, you can show off a little bit, I guess. It's okay. So we do a lot of this folding and do some really complicated things in the engineering week. And so this will kind of be an introduction for those of us who aren't here. And that's why I wanted to have an atmosphere where we can collaborate. So when I take the students through this, I make sure everyone has a piece of paper, let them choose their color. And then we start off with just one sheet of paper. And I really like to talk about a lot of vocabulary as we're doing that. So I'll ask them, you know, what shape do I have in my hand, or do you have in your hand? And what would you say? Square. And then I ask them, well, how do you know it's a square? 4 equal sides. How else do you know it's a square? Right angles, right? So there are all of these attributes that shapes have that give it the name that it has, right? Because there's a lot of shapes that have 4 sides. But saying 4 equal sides kind of narrows it down to what that shape is. So we're going to take our shape, and you're going to have the white side up. And you're going to take the 2 edges to the center, and you're going to eye it the best you can. We don't want to make a crease, but we're going to eye it the best we can to take them to the center. And we're going to make sure they're touching, but they're not overlapping, and as little white space between them as possible. When I do this with students, I tell them, what does precision mean? They get a lot of great synonyms. I get being careful, you know, being precise, being exact. And I ask them and I tell them, let's be very precise as we work today. Because being precise is really important when we're doing origami. So we take the 2 edges to the center as close as possible. We don't want them overlapping, and we don't want very much white space right in between them. All right, so we started with the square, and now what shape do we have? A rectangle. But how do we know it's a rectangle? All right, 2 sides are shorter than the other 2 sides. So the opposite parallel sides are equal to each other. We still have 4 right angles. That's correct. All right, so you folded your edges to the center, and now we're going to rotate it 90 degrees. The flaps are facing you, and you're going to take those edges to the center again. Eye it the best you can. Don't overlap, and try not to have any space in between. All right, so pure origami is 1 sheet of paper and you fold it and you create something else. And I like what this professor once said. He said, origami is changing the memory of the paper, right? So leaving the paper just like that, it's still gonna keep that shape because I changed its memory. It's gonna stay that way, right? And so what we're gonna do is we're going to create modular origami. So modular origami, you're still not allowed to cut, but you're using different modules to put them together, right? Without any adhesives. So that's the key factor. So that's why your folding needs to be really precise when you're folding. So I tell the students, you know, if you have your flaps here, your tabs here, sticking way out, and you see that this is not a crisp fold, you want to go back and you want to slide your nail across it. Because this piece right here, these tabs are what's going to hold that form together. Right? So I want you and your partner, if your partner, I think you can do 2s everywhere around. So you and your partner need 6 of these all together. So make another 2 each, whatever colors you want, and then we'll come back together so I can show you how to put it together. Oh yeah, because we need to put it together. We'll just put it there. Yes, 6 total. I have 1. I have 2. What color scheme do you want to use?
Primary colors.
Okay.
I know.
You have to look around to people who attended to his color scheme. Mhm.
Yeah. I don't know if you see that in the
Nope. I don't think they would unless they were. That's the thing. Like, how do we get kids to break down the walls between their classes and use what they've learned in one into another? That's still
They
hard.
could just be there walking by at the right time and they were already kind of like kids that look at that, you know, like
Mhm.
some kids are into that. I think we can also use the tint of that would look cool too.
Oh,
To
yeah,
have the
that would.
contrast of the tint of the primary color. I love this paper. In fact, people that come in my classroom and say, that origami paper. I'm like, they only get any one. Right? Isn't that
Yeah.
what you
Well, we have a whole cabinet of it,
said? I know, that's awesome though.
but I don't think you can buy it anywhere. Sweet. That's cool. Mhm. What is our time right now? We're like at 5. We're like 5:08. Yeah. No, that's great. I think it's good. It's a good. Paul said just to have like around 10 minutes, 15 minutes at the end in case people have questions.
I'm trying to stay. How long did you not that I feel confident.
It's perfect. Most people are finished.
Graduate admissions, I'm not a faculty member, but whatever I can do to make the bond stronger between names and FPU and all.
Like one more.
Yeah, and then yeah, but they, you like there's one fold that you did it wrong, that it wouldn't work. Yeah.
I think most people are. So like the second row behind you are all like STEM masters. I think everyone else is not. Oh, the couple in the back is.
Saying that his abstract by design, they just threw out season 2. Women from Israel and Paris.
I was just watching that today.
I was just like, I watched it last night, and I didn't even pick it. It was somebody else turned it on, and I was like,
I was just watching it today, and I was like, oh my goodness! Like, did you see the thing where she does about the
yes, I was like if we had seen this other people,
Oh my God.
we might even reference that. I mean,
Yeah.
I was thinking you might reference it or something. I'm sure you already are referencing it, but I loved that illustration.
That was very cool.
That really made sense to me. I was like, and how is this? She's so young and beautiful.
I know.
I'm like,
She's an MIT professor.
she's a professor at MIT, and she's like in the military, and she's like a surgeon or a medical doctor.
Yep.
And then an architect, and
And something
last
else,
thing.
I forgot. She was using like plastics to create.
Something like bioengineering.
Yeah,
or something.
bioengineering.
Yeah. But I was like, I'm going to show my students.
Yeah,
Because
that'd
we're
be
in
really cool.
perfunctory, so like my job is to like spark inspiration. And so I've already shown them a few from season 1.
Wow. I never even heard of the series, but I just saw that today. The abstract art design, the
And the
design.
most, I love season 1. There's one on, her name is, her last name is Cher. That's her first name. And she's the most well-known, celebrated typeholder. And women too. And she's in New York City. And so many things that we look at every day that are cool designs. She also did lots of record albums in the 60s and 70s. Album covers, and she was the font designs. anyway, so she goes through, like, it shows her in her office and how they brainstorm and how they come up with ideas. So, like, it shows them how they designed the Citibank logo, the little red, because of the, like an umbrella.
Yeah.
Anyway, and so I thought this was great because students can give ideas.
They can see the relation to this.
Right, and how they're like thinking aloud, you know, they're like, and then I have them design their own type font on their name card. It's like their very first project, and then they do this thing, you know, anyway,
Oh, let me get them. Yeah. All right, so I'm going to bring everyone back together. And I know some of you already did it. So with these 6 squares, we're going to create a cube. Okay? Each of these are one face of a cube. And the face is the flat area, right? So we'll do that together. I know some of you are trying it, but we're going to do this together. So you're going to take one of your colors and lay it down on your table. Okay? And then you're going to take 2 other colors. If you want them to be the same, it's up to you. But these are the lateral faces, so the parallel faces that are on each side. And so if you look at the tabs here, all I'm going to do is I'm going to lay these other tabs inside just like this. So I'm not really inserting any tabs in each other. I'm just kind of laying them there, and they're going to kind of, they're not very stable right now, but you can kind of insert them, and your tab's going to kind of hold it just like that. Right? So you have your tab from your blue that's on your base, and then your ones that are facing each other that are parallel are just kind of inserted inside and just facing each other. Yeah. Right? So then what you're going to do is you're going to take another color, and instead of the tabs coming like this, like they're horizontal, you're going to make, vertical, you're going to make them horizontal. And all you're going to do is stick them inside of this little area right here so that they hug the tab that's in between. That blue one for me. So let me do that first. So it's going to be just like that. So you have nice clean edges. Yes. You're going to put it together. Perfect. Do the same thing on the opposite side. Make sure your tabs are horizontal. And then you're going to put your top right on. All right, so hold up your cube nice and proud. Let's see all the cubes around here. So Leslie can see the color schemes that you used. Were there intentional color schemes? No? All right, so let's talk a little bit about the math vocabulary. So what shape is this? It's a cube. Is it an implied form or an actual form? It's an actual 3D form, right? So how many faces does it have? This is smooth sides that we have. 6. We have 6 faces, right? And when faces meet other faces, they make this, which is an edge. So how many edges do we have in a cube? 12. Yeah, we have 12. We have 4 on the bottom, the 4 straight up, and then the 4 at the top. Okay. All right, and right here where 2 edges or more than 2 edges meet, sometimes like right here, you have a vertex, plural vertices. So how many vertices are there in a cube? 8, right? 8 vertices, right? So it's it's so powerful to see the implied form become an actual form. Because now, just like, I love how Leslie describes it, like if you close your eyes and touch it, it's not flat, right? You can hold it and you can move it around and you can rotate it, right? And a lot of very young children, especially, they're very used to seeing that just implied form, right? When you talk about 3D, it's always an implied form, even if it's like a nice screen, right? Or in their book, it's an implied form. But to actually kind of see that and hold it and see what a face is, right? To touch a face of the cube, to hear the word, right? And to be able to say it. More of those connections are being made. All right, so we're gonna do another. We're gonna do another form here, another solid, and you need 3 sheets of paper. So this is one you can make on your own if you like to. You might need a little collaboration when we're putting it together. So pick out 3 sheets of paper. And once again, what we're gonna do to one paper, you're gonna copy 2 more times, right? So we said that how many faces are in a cube? 6, right? So in mathematics, when we talk about 2D shapes, flat shapes, they're in this big group called polygons, right? And so we have shapes that have 3 sides, and what do we call them? Triangles, right? There's all different kinds of triangles, right? And then we have shapes that have 4 sides, we call them quadrilaterals, and that includes squares and rectangles, parallelograms, trapezoids, and all of those. So poly means many, many sides, we have polygons. So when we go into the 3D realm, we have polyhedra, right? So many faces instead of many sides, right? So we're gonna make another 3D form, but it's still gonna have 6 faces, but it's not gonna look like our cube, right? We're gonna make a different one. So what we're gonna do is with the white side facing up, you're going to connect the 2 opposite corners. So we call that folding on the diagonal, because that's the diagonal, the line that connects those. So you're gonna fold on the diagonal so that when you fold your shape in half, you're gonna have what shape? Triangle. So we said there's lots of types of triangles. So what kind of triangle is this? A right isosceles triangle. Extra credit right there. All right. So we have the shape. Okay. And we talk about being precise, especially when we're with our students. We want those corners to meet nice and straight. All right, and then we're gonna take these 2 vertices and we're going to join them. So we're gonna fold our triangle in half. What we also talked about when we did the lesson, I remember, is we talked about similar and congruent, right? So we talked about that with the square that we started with, and then the square we ended up with the cube, that those were similar shapes, but they weren't congruent, right? So that's what we just did right now. We have this triangle, and when we fold it in half, we get another triangle that's the same shape, but it's not the same size. So that's where we say it's similar. All right, so I wanted you to open it up so you could see that crease that you made in the center. And I usually have students like turn it so that it's pointing downward. This. So I can see the crease. And you're gonna make these vertices to the point at the bottom, both of them. And down again. When we did this in Leslie's class with the cubes, I let them I had enough time so I can let them experiment and try to put the cube together. And some of you were able to do that without me giving them instructions of how to put it together. And I said, this is like a puzzle. See if you could put these pieces together. And they were really amazed. The ones that put it together, they couldn't believe that it went together so clean, that it was just a clean shape. All right, so now you have a module. So you're going to do the same thing to 2 other sheets of paper, right? Fold it in half on the diagonal, fold it in half again, bring it out, and then put those 2 sides to the bottom.
At first, some of them were like, they were folding paper, and as soon as they saw one finish, they're like, oh, that's no way.
And they all were kind of like
And then they're like,
engaged. Yeah,
yeah,
that's true.
because they didn't see what the, as soon as they could see the outcome, they're like, you did that? Are you sure? I know I need to, but I really wanted to do a pastel, and I hope you don't mind.
No, no.
I brought my drawing, but I don't think anybody used it, just in case. I brought my drawing of how I remember how to do this.
Yes, I remember that. Put the ears inside.
That's actually like how I remember how to do it. Like I remember that.
All right, so similar to the square, these right here are flaps. These are like our tabs that we're going to use to connect the shape together, right? So if you see the shapes that we have, if you think about these triangles right here as our tabs, then right here, similar to what we were doing before, is that face, that square face. But we have a crease, and we're cutting it really into 2 triangles, right? So what we're going to do is, it's like a little cycle. So these 2 tabs fit into a complete face here, and they slide in. And you want to slide them almost in, but not all the way, right? So you can see from both sides that I just have the tab in between of that paper, right? And lined up to the crease that's right there, okay? So just 2 of them. So walk around. So I have the square here, but then the tabs here.
Oh,
So yeah, like this, right?
like this,
Insert.
but insert it.
Yes. Yes. Mhm. Yes, so you'll have one. So you have one square and then a tab, one that has a tab. So
Yeah.
like this.
It's like it's a little cup.
Well, how did, why, okay.
So just
So
there's
my
like
tab,
this,
okay, got it, okay.
and that will go in there. So with your remaining color, you're going to do the same thing. You're going to stick these tabs into the face of that color that doesn't have any sticking out. And then you're going to stick these tabs into that one. So you made a little cycle. Tab into that face part. So you're missing a tab on that one. So you'll need to pull it out and
All right. Okay, here we go.
so tabs into the face.
Oh, inside. I didn't see that part. That would have been.
And the blue tabs in the orange and
Yes.
these in the blue.
Got it.
So if anyone's a visual learner,
Yeah.
I don't know if this helps, but like if you think of it as a top,
Mhm.
here, go underneath.
Into the mouth.
Good. So, so this way.
That's why it was so.
Mhm. So then these tabs in the yellow and then. Thank you, Robert. Got it?
I think, is that right?
Yes. So did you see that there's 6 faces?
So sorry for the old lady here. No mercy. No.
It's not square.
No.
They're not squares.
What do you mean, no? It's not right?
Yeah, that's right.
No, I said no to no, to sympathy.
So we said it would have 6 faces, but how many edges does it have?
6. Oh, edges.
Edges. How many edges? 9. So very similar to the square. You see the base is a square, that 4 sides, and then they each have to go up and then meet with that top. You have the same thing happening here. You have the 3 in the bottom, the 3 going around, and then the 3 going to the point at the top. How many vertices? 5 vertices. So we can't call this a cube, even though it has 6 faces, because our 6 faces are triangles instead. So what do we call a shape that has 6 faces? Hexahedron. Hexahedron. All right, we're going to do one more fast. All right, this is going to be collaborative. So you'll each need 3 sheets of paper again, and you'll make it with a partner. You each need 3, but it'll take 6 total. All right, so when you take your sheet of paper, you're going to fold both diagonals in. What you have to remember is the color side is out. So you're going to fold in both diagonals, so you'll have an X when you're done, right? An X right through your square. Color side out. So you'll fold it one diagonal, you'll open it up, and then you'll fold the other diagonal in. So you have to think, a lot of people are like, well, why can't I just fold it again in half? You get more precision when you open it up again and then meet the vertices again. So that's why we want to open it up when we fold it in half each time. So after doing that, you have your diagonals folded in to your square, right? Just like that, right? Now what we're gonna do is we're gonna fold it in half horizontal and vertical, but we want the white side out. So we want to do this to the same sheet of paper. Both ways, yes. So we have a total of 4 lines going through our square. They're all meeting at what intersection? The center of the square. And you see, because we flipped it over, that if you take the corners, they'll come together kind of like in this star shape. And that's what we want it to happen. That's why we have the white side out and then the color side out and then the white side out, right? So you're gonna make 2 more of these each, and then I'll show you how to put them together. I have one. When we were folding the last one, I saw some of you walking around and helping other people. We saw the same thing with high school students. You know, they were helping each other put them together, having a lot of discussions about how did you do that? Come help me. There's a photo of this one, 2 kids putting it together. Their hands are on it. Two, 3, 4, 5. That's fine. One more.
Try to get super precise. The more I try, the more I.
Color side. This way? Color side out. Color side. Yeah. Ooh. Yes, sir.
So can you build a regular tetrahedron? How do you do equilateral triangles?
I've done one of those, but you have to have the a ratio of the paper cut in a certain way. You can't do it with a square.
Can't do it. That's what I wondered. Well, Paul brought me that little hexahedron.
Hmm?
What do you call that? Yeah.
Just
Do we have it?
hexahedron. I don't think so.
It's like 2 pyramids
Yeah,
put back to back. But they're all congruent.
Mm-hmm.
But what's interesting is it's a 6-sided shape, and opposite. See, on a regular tetrahedron, opposite a vertex is always an edge.
That's right.
See, with a cube, opposite a vertex is a vertex, opposite an edge is an edge. Well, this is 6-sided,
Yes.
and opposite a vertex is always an edge.
Isn't always.
I had never thought of that. I mean, I've built this shape for one reason or another,
Mhm.
but I never thought about this. This is the first time I noticed that why this just never came up.
Yeah,
This is good.
thank you.
I think it's nice you're doing all the shapes.
Yeah, thank you. That's one word. Almost done? Almost done? Okay.
Colors are all side by side on the color wheel. Anyway.
Alrighty. Let's see what our time is. All right, so we're gonna start putting this together. We're gonna make an octahedron. So how many faces will we have? 8 faces. It's a skeletal octahedron, so that means that it's gonna be concave. So it's not gonna be smooth sides like this, outside. So what you're gonna do is you're gonna take 2 of your colors and you're gonna help each other because all 6 of yours are gonna fit together, right? So one of you, go ahead and take your 2 colors and you're gonna put one of the tabs into the other. Just like that. Okay, slide it all the way through and then you're gonna pinch it to hold it, right? So this is where maybe your partner's gonna help you. Because what you're going to do is you're going to make a little cycle of 3 colors here. So see how I have the blue going into the green? Okay, so then I'm going to have the green go into the purple and then the purple go into the blue. So I need to make sure that every color is showing in one of those little areas. So you can see right here, I have all 3 colors, one going into each other. And you still have to hold it together because it's not kind of locked in yet.
You need to make sure that
So actually, one of you build this and then you'll build off of it.
Okay. Build
So
the 3.
build the 3
Okay.
first.
All right.
And then you're going to choose either this side or this side to work on.
Okay. Oh.
So you choose this one, then you want it'll go inside the yellow.
Gotcha.
And then your yellow
yellow
will
goes
go,
inside the blue.
Is that right?
it'll go, yeah.
All right.
And then so you can turn it over and you can see your triangle there.
Oh, yeah.
Okay. Here we
Okay.
go.
All right, so once you do that, you can start adding colors. So you can see over here I have the blue and the green, but I have 2 greens showing, so I want to cover one green and put it inside the blue. And you kind of just want to keep building off of there. Oops, you're like, don't walk over here.
Oh no. No, the reality is we were exploring how they fit together and we must have missed a very important step.
Yeah.
So what's the first one? You put this one in like that.
And then you put one more color. So you need 3 colors together.
Oh, okay. Like that?
So which you have to choose, like, so which way are we going to work on? Are we going to work on this side?
I don't know. Sure.
Okay, so let's look at this. So you want to cover a purple so the yellow shows, and then it goes in here.
Oh, so you have 3.
So you have 3. And
So
then you're going
each
to bring
like-
it out so that's connected, just like that.
Okay. So each thing should have a 3.
Yes, 3 colors are showing. Well, if you choose different colors. Okay. Want to add yours?
So
Okay.
there's 2 greens on this side, 2 purples on that
one
side. I think one of them. I think both of these go this way. Okay. Because then otherwise there's no key.
Okay. Yeah. And then this one goes over. Oh, I assume this is because we already have that blue. Should I? Okay. I didn't realize we had one too many. Okay.
Oh, do we have one? Is that the top?
I don't know.
That is the top. You're right.
I just realized all of a sudden, I'm like, oh, is it already that big? Wait, no,
Something
sorry.
like that. Oh yeah, there it goes.
Yeah, this one goes in.
Oh,
I was so worried about my color scheme.
you guys got it?
I think so.
Awesome.
Okay.
So what do you guys think about how the shapes are similar and different from each other? All three 3D forms that we made.
Yeah, it's kind of, I don't know, whenever I'm finishing it, I don't know if that's what you're supposed to do, but I
Yeah.
always kind of just
Push it together.
wiggle it around a little, give it a little, like,
Kind of separated too. It ended up being like you put other colors around
Too bad I didn't bring another one of these. Oh, I do have one in my bag. Yeah, you should have 6. It looks like you have 6. You're covering this color, and it should show.
But then this one, how do I have double?
This one needs to go in. Yeah, so that you only one. So this one's.
Okay, and I see that's in the air. Yeah.
So we're just going to quickly reflect on what the students did. We're going to show you some pictures. Show you some pictures of the students and how we went through this. It was a block class. So how long is a block class, Leslie? Like,
our block schedule is almost 2 hours. It's like an hour and 53 minutes.
yeah, so we had a lot of time to work with the students. Should I show them what they built?
Yeah, they were. Okay, so also you should know that the thing at Sunnyside is, don't take my picture, Miss Patty. Don't take my picture. Nobody wants their picture taken because they're afraid you're going to post it on social media. And, but for this project, they were like, they saw me trying to get some photos. Don't worry, I'm not getting your faces. They're like, no, it's okay. You know, there's another
They were
one where
really proud.
some of the students who hardly ever, you know, they're always like the last ones to even start their project, and they're kind of resist getting engaged. They try really hard not to. But they eventually will give in. Well, these two, I don't know if they're in the slideshow, but they have theirs, and they're holding them all up, and they're all like peace signs. And I couldn't believe it that how much the kids were so proud of them.
And we saw them, like you can see here, building towers together with what they had made and using the cube as their connector. So laying that cube inside of the space and then building with them. And honestly, I've never seen anyone do that before. I've done this a lot with different students and adults, and they were seeing how they could build. And then one of them was, I'm saying, yeah, I'm going to be an architect. And so he was really engaged with putting the shapes together. So you want to talk a little bit about the exit tickets?
Sure. So I use the exit ticket sometimes, not every day, but the 3-2-1 exit ticket, I really like. It says, name 3 things you learned in art today. And so some days when I don't have time to really plan a specific questionnaire for a project or a video or something that we watch, it's a really great way to have them think about what they learned. So name 3 things you learned in art today. Number 2 is list 2 things you want to learn more about. And 1 is ask 1 question about today's lesson. So maybe all of you already know about this, but we don't do this at City College. So, I mean, I didn't. So I thought this was so neat when I first started the credential program. Like, this is really cool. Anyway, so did you want me to say more about that?
Yeah,
or-
if you
okay.
wanted to highlight. I just put 2 of them up here.
Okay, so this one says, I learned about the history of origami, how it originated from Japan, and how origami is useful in real life. I also learned how to make a 3D cube, in which I found it simple. I also learned how to make a hexahedron, and although it's only consists of 3 papers, it's complex to do, I think, to attach, maybe. Okay, so that is a very well written one. And so she did tell us all these really cool things. They still talk about, like, oh yeah, they use that one to put stents in the heart, or like they use that one in the space shuttle, and so that was so fascinating to them. And then 2 things you want to learn more about. I want to learn how to make animal origami, and I want to learn more about how origami is used in real life. So that was very interesting to them. And they're the future. So we want them to be very interested in how we can apply these things to make life better. Ask 1 question about today's lesson. How is origami more than art? So that's a very good one. This one is, I learned how to make a 3D cube. I learned how to make a heart. I think it's a heart, and different angle. 2 things, I want to learn more about 3D, hexahedron, vertex, and more. I want to learn more about edges and faces. And she told us that edges were 3D, which I didn't know. So sides versus edges, and edges are 3D. So we were like, wow, okay. So it was neat to kind of differentiate between some of those terms. Ask 1 question about art today. Ask 1 question about today's lesson. Are we going to make more? And they do still ask me, when is Mrs. Rizzo coming back to teach us again? They really enjoyed it so much.
And then to follow up, created this crossword puzzle for them to do afterwards, to go over the vocabulary again. And we were collaborating about that as well, because if you go to the internet and get any vocabulary definition of that word, but then to really use it in the context of us folding, we had to like kind of tweak some of those definitions to make sure that they made sense in that context. So that was one great way to kind of review it.
And I think it's really important for teachers to talk to each other about this, especially at secondary level, because the students are going from my class into math class into, and if we're talking to each other and comparing, this is the definition, because at first I got some definitions and I said, I think these would work. They're from a math site. And so she said, well, and so there were a couple that needed to be tweaked, but I think that would be important so we have consistency as well. And also vocabulary is a place where visual arts can really meet Common Core standards. So vocabulary is important for us.
Definitely. So just a couple of pictures of Leslie's class. And I want you to notice those amazing paintings on the wall are her actual paintings. And when I walked in there and I saw that, I really felt like a sense of trust between her and her students, and a sense of like honor and respect for her to actually hang her own paintings in there. And for them to know that their teacher was a content expert in her field, and is an active person that is working in her field as well. And so that was really powerful to see that and to be a part of that classroom atmosphere. I just wanted to also share, we still have some ideas of where we want to take this, not only in folding paper, but beyond, of different things that we can do with mathematics in the art classroom. And really the idea that a lot of what starts as that creative piece that becomes something that can change the world happens with a picture, something that we visualize. Maybe we don't necessarily sketch it, but we imagine what that would look like, or we have some vision or perception of what that could look like. So we kind of wanted to leave you with just really a call to action, because the future of humanity depends on how we collaborate together. And you don't have to choose if you're the math person or the art person. You can be both. You have a right side and a left side brain for a reason. You have both of them, and connecting them and using both of them in those creative spaces are so powerful. What we wanted to do for these students is to show them that they belong in both of those places, and that while art is trying to bring out of them a sense of communication, empowerment, and expression, math really should be doing the same thing. And that's how math classroom should be, and maybe that's how art classroom should be as well. And so seeing that collaboration with the students was really amazing. There was a day that I was there for some of the lesson, and then I had to leave, and then I came back for another section or another period. And Leslie shared with me that one of her students says, "Is this really math?" And she's like, "Yeah." And he's like, "Don't say that, you're going to ruin it." Right? And then she told him, "Well, maybe math isn't what you think it is." Right? And so to kind of open and broaden their minds that math is something that is powerful, and it belongs everywhere, but so is the arts. And so bringing those two things together, I think, is really interesting and neat. Like I said, I've worked with science teachers, I've worked with engineering teachers and math teachers. This was the first time I put myself in that art space, right? And that art space was really comfortable, but it was a place where I needed to grow, and I needed a sense of being what a novice feels like. And that's important for all of us to put ourselves in that area. And I want to just, again, thank Leslie for opening up her classroom and being vulnerable and willing to experiment in those ways. And if there's anything else you want to share before we take questions. I think
there was a quote that I heard yesterday, actually, and I thought, it just hit me so profound. And it was that imagination, or that technology advancement follows imagination. And so imagination has responsibility.
That's right. So we'll just have a few minutes if there's anyone that has any questions about the work we did together, or any questions that you're interested in.
What's the earliest grade level you would suggest art?
I've done like the cube with 3rd grade students, and I think I brought just the actual regular size paper and cut it into huge squares, so the pages were bigger and that paper's thicker, and they were able to make cubes, and they were really, I mean, they were very engaged. And so they were doing a little bit of the beginning stages of what volume is and what 3D is, but that was really interesting for them to see it. And they were doing it at home. The teacher was saying to me they were building them at home, and that wasn't their homework, right? So they were engaged so much that they were bringing that into their home spaces, and that's what we want. We want that home to be places where the school and the home kind of have that line, you know, not strong and diverse and barrier-like, but a place where your school math becomes your home math, and your home math becomes your school math, and that was really interesting. Anything else? Yep.
I'm interested in, as Nathan and I were working on this, it wasn't perfect, and we made some mistakes. And you know, in math classrooms, we talk a lot about accepting mistakes, and that mistakes are these like building blocks that we can use. And so I'm wondering, what do you tell your students about mistakes in art class?
I call them happy accidents. I said sometimes mistakes are actually happy accidents. So maybe you didn't intend to do something, but before you throw it away and crumple it up and try to start over, like take a second look, because every artist I know treasures happy accidents. So sometimes things just happen and you're like, wow, I really like that. What could I do with that? And also another thing that several like colleagues that I have that are practicing artists, they say there's nothing more intimidating than just the blank canvas. And so even if you accidentally splatter some paint on it and you're like, oh, that's not what I wanted to do. You're like, oh, you know. And so I have to say that every artist I know will say that. So the students really find, I think that they find a way to feel relaxed and more comfortable. And also another thing that I do tell my students, because this is their first art class for many of them. So we do something when we're studying line and organic line versus geometric. And we put our hand like this on the table, and I give them 2 pieces of masking tape to tape down their paper. And then we talk about video games. When you're playing a video game, where are you looking at the screen? Are you looking at your hands moving the buttons and the joystick? No. So it's hand-eye coordination. We're gonna practice that today, and drawing, because really drawing is a way of like meditation, of really seeing something, and like looking at it really very carefully, and that's hard for beginning art students to do. So continuous line drawing is a great exercise, and I'll say, I want you to just don't look at your paper, just look at your hand and never lift your pencil up. It's gonna be one line. The whole thing is like one thread. And you can go back over, but you have to follow it with your eyes and like let your hand trace it. And every semester, every class, they say, Miss Batty, it's gonna be ugly. And I said, I want it to be the ugliest map of all the edges and creases of your hand. Make it, in fact, if the more ugly, the better, the more points you're gonna get. And so then their drawings turn out amazing because they lose that pressure that it has to be perfectly proportional and everything. And they look amazing. I brought examples if you want to see, but anyway, so I hope that answers your question. Okay.
I have a comment. So I teach science, and so we have them make drawings, but we never tell them how to draw or give them to the drawing class. So I decided this year I'm going to streamline it a little better, and I started by giving them like, okay, here's a handout. And you're going to just draw letters, block letters, and line letters, and one that I had gotten from a website. And so I get called into the principal's office because the parent complained that, what does this have to do with science? And I said, well, if you want me to talk to the parent. And so the parent was upset. And I was like, why would you have them do that? And I said, well, because we need to slow them down. We need to have them like look at their drawings, and when we slow them down, they start paying attention at the idea. And so when you said right now, you have to like slow people down. So that's what I did. But the principal was like, yeah, and I want to know too. What does that have to do with science? It has everything to do with science.
Well, and just observation, being careful observers is scientific. I mean, that's a scientific practice, right? Absolutely.
Well, join me in thanking.
And if you have other questions or comments that you want to make, I'm sure our guests will stay after for a minute, but you've inspired me. I think that I can speak for everyone that to think about mathematics and art as integrated is a powerful way to reconsider the things that we do both in art classes and in mathematics classrooms. So thank you for that, Aileen and Leslie, and thank you all for joining us tonight. I just want to say our next colloquium is November 4th, and Alexandria Hansen will be joining us. Alexandria is a professor at Fresno State. She'll be talking about science teacher education in the world of digital technology and NGSS. How do we continue to think about science education through community partnerships? So hopefully you can join us on Monday, November 4th for our final colloquium in this series. And again, thank you for being here. I think these things that are made are free to be taken along. So fight with your partner or who gets what. And we'll look forward to seeing you next time. Thanks, everyone.
Thank you.